Now we are going to look at a notion called a single page application and a related concept, right? So there are a couple of different things over here which have emerged as a result of all these new technologies in the web browsers, okay? So let's first look at what the web application user experience used to look like, right? The original web applications. You would have HTML which is received by the browser, it would be rendered, and all navigation from there on is handled by links or posting to forms, okay. So anytime you want to load a new page, the server gets a request, it renders the page if necessary or just picks up the HTML if that's all, if it's a static page, and sends it over to the browser, okay. Now form submissions, for example, right, are processed and any resulting output is rendered on the server, right. So in some cases the server would actually like have new HTML being generated, or it might just have a sort of thank you for submitting kind of a standard template HTML page which it sends back, right, once the form submission has been successful. But every single such click, right, any interaction is ultimately going back to the server, and you have these round trip delays which sort of becomes very obvious when you are actually working with the system, right. It's very clear that every time that you click on a link, it is going back to the system and then coming back, and you have this page being refreshed completely from scratch, okay. And one of the questions that came up as these technologies progressed was, look, how do we make something like this more fluid, more sort of appealing to the end user, right, something that looks more like an application that they are used to on their desktop, rather than something which is clearly a web page which sometimes goes into this loading mode and takes a long time to refresh and so on, okay. So the alternative that slowly built up over time was, let's handle navigation as far as possible on the client, right, and asynchronously fetch only whatever data is required to update parts of the page, rather than just getting the entire HTML back from the server. You can go one step further and say that, look, if you are anyway handling the navigation on the browser, right, but you still want to give the user the feeling that they are using a regular navigation through a web page, maybe handle the page history and the transitions also through JavaScript, right. So basically you have several APIs that are used through JavaScript in order to enhance the user experience, okay, which finally sort of leads us to something that is known as a single page application. So a single page application is typically a dynamic website, something which has to change, right, it's responding to the user's inputs, because otherwise it's just a static HTML page, right. Why bother calling it a single page application? That's not what we mean by a single page application, right. So in a single page application, it is dynamic, things do change over time depending on user input. But what we are going to do is rewrite the current page as far as possible, right, instead of re-rendering with a fresh load. Why do we do this? It's primarily for user experience, right. It feels faster, the page loads sort of occur instantaneously, right. It feels much more like a native application, right. And these kind of single page applications, there are any number of them that you probably use on a daily basis. The Gmail web interface is an example of a single page application, right. Pretty much everything over there is handled with JavaScript, but done in a clean way, so that for all practical purposes it almost feels very close to a desktop application. Having said that, it is pretty much completely in online mode, right. That's one of the things. There is an offline mode which we will get to later, that's a different story, right. How exactly is offline implemented? Facebook similarly is something which is completely online, but it does require the server, right, but all the navigation, all the updates and so on are handled on the client, which is why you have a nice smooth user interface when you use something of this sort, right. And Google Maps, in fact, you might recall that the whole Ajax concept, one of the driving factors over there was this implementation of Google Maps, right, in the 2004-2005 time frame. What exactly did they do? What they said was, as you sort of zoom into a part of the map, rather than sort of going in and saying every time you click we'll go and load a new page, the loading of the image data was happening in the background. The system was basically picking up, okay, which way are you zooming, which pages, which parts of the map do I need to load next, and based on that it would then go in, send continuously, it would be sending requests to the server in the background, right, which is why you will actually know that as you try zooming in a Google map, it takes a little bit of time before the thing sort of actually zooms in, right. Sometimes you see this slightly blocky looking thing and then it gets overlaid with the actual data. What's happening is that a fetch occurred in the background, right. New data came back from the server and that is what is being displayed on your screen now. Okay, of course it's also being cached efficiently and so on, but the fact was that the fetches happened in the background without you needing to go to a new page. So Google Maps in that sense was probably one of the best instances of what a single page application could look like. But nowadays there are any number of them, right, that you could see around you. So there are many different ways in which something like a single page application can be implemented, right. So we'll look at some of the older techniques first, right, and some even newer techniques before we sort of look at how you can do it in something like Vue. Now keep in mind that a single page application does not automatically mean that you need JavaScript, right. If all that you are looking for is something where what is displayed on the screen is something that changes with time and can be controlled through some kind of clicking or something of that sort, you could actually do it completely with CSS, right. CSS allows you to selectively display certain document elements, right. So you could have one large HTML page where there are different sort of divs or something like that, or containers that have specific IDs and they get different classes in CSS associated with them, right. And depending on which class is there and which one is to be shown, right, you can change whether something is actually displayed on the screen or is it just sort of taken off the screen, right. So you could transition between different things at one shot, right, purely with CSS. Now of course what it means is that the entire page with all the information you need has to be loaded right up front, right. Usually that means slower load times and using more memory, right. And at the end of the day, except for the fact that it allows you to show multiple different static pages and transition between them easily, it still doesn't do much in terms of interaction. Now for a long time, right, the sort of dominant way by which you would have these kind of applications inside a browser was using various kinds of browser plugins, right, things like Java applets, Shockwave Flash, Silverlight from Microsoft, right. All of those, the idea of those things was that you did not have enough power inside the browser to handle something of the sort, so let's put in a custom runtime environment that can handle things for you, okay. Now usually what ended up was, there was significant overhead. Even though Java applets sounded nice, anybody who's used a Java applet would know that, I mean, the moment you hit a page with a Java applet, it's a bit scary, right. I mean, the whole thing slows down, the Java VM is going to start up, it needs to load the applet, it then shows loading. It was not a very pleasant experience, okay. It does allow the web developer, right, to give a very good sort of experience in certain ways if it is written well. But overall the bottom line is that it made usage sort of more complicated. Now of course the most common one is Ajax, which has now developed into various kinds of fetch APIs, right, where what you do is you asynchronously fetch and update just parts of the DOM, right, and it's very popular with existing browsers. So modern browsers have all these new JavaScript capabilities, and more importantly modern hardware is sufficiently powerful that it can run it pretty much in real time and give you a very smooth experience when you're trying to run with something of this sort, okay. It does require powerful rendering engines. What I mean by rendering engines is the part of the processing that actually converts the HTML into something that gets a set of pixels on the screen. That's the rendering part, right. And because of the fact that things are changing so fast, all of this has to be done in the browser in a fairly efficient manner. Now there's one other approach also which is even one step beyond what you would do with fetch APIs, which is there are certain kinds of asynchronous transfer models that exist between browser and server, things like WebSockets or server sent events that actually allow for even better interactivity than what you would normally see with frameworks that use JavaScript, right. In particular, the server can now push updates, okay. So even things like, for example, having real-time chat or video conferencing, right, or push notifications, all of those are handled very efficiently by means of these server sent events and WebSockets. Okay, but in general those are a little bit harder to implement. They are, in terms of interactivity and the kind of experience they give, they are probably the best in the line, but they are harder to implement than just slightly more simple framework based JavaScript. Now all of this has certain impacts on the server as well, right, in terms of how you go about designing and using the server. We can broadly sort of think of it in a few different classes, right. So this is sort of the way it is described on Wikipedia, for example, which makes sense, right. I mean, this classification over here is a good way to think about the different ways in which servers can be thought of. Okay, the first and most important thing is the moment you have this kind of separation out here, right, and you are trying to increase the load on the client, more of the processing load is going to be handled by the client, right. The navigation and deciding which component to load, even most of showing the different parts of the components is all handled on the client side. The server actually becomes simpler and potentially thinner meaning that it does not really need to do very much. In fact, you could potentially have a server whose only job is to respond to API requests, okay, and the rest of it, everything else, is displayed on the browser using APIs, right, and JavaScript and whatever markup, HTML or the equivalent that you have there. Okay, so that essentially brings in the notion of a thin server. Usually we have what's called a thin client, where everything is handled on the server, right, and the client is just a sort of dummy front end display. Over here we are talking about the opposite, which is the client takes care of a lot of the bulk processing and the server's job is simplified. It just needs to sort of respond to API requests. On the other hand, you could still go back and say, I still want to have a thick and stateful server. Thick meaning that it has the entire system state, right, associated with it. It also has the full state of whatever is currently being displayed on the screen. Okay, and if you think about it, right, a single page application, right, the point that we are trying to make is we don't want to be re-rendering the page each time, but if I do need to fetch information from the server, as long as it's done in the background and sort of updated in place, I would still consider it a single page server, single page application. So even in the context where I have a server that is like got complete information about the present state of the system, right, and keeps updating what needs to get displayed on the screen based on any new sort of request update from the client, it would still be potentially a single page application, right. So when you look at this is when you realize that single page application can be a little bit shaky in terms of its definition, right. After all, if I'm making all my fetch requests to the server and pretty much getting all the data that I need from there, what's so great about the SPA, right? And sort of the main defining characteristic at that point is the fact that it's not explicitly re-rendering the page from scratch each time. Is that really so big a deal? Well, that's where things get a little bit tricky in terms of whether you are defining something as an SPA or just as something which is corresponding to a thick server which transfers all the data. Okay, you could also potentially have something in between these two, right, which we call a thick stateless server. Now this is interesting because what it's saying is the server still handles most of the computation. It decides what needs to be rendered on the screen and so on, but it is stateless, meaning that it's not actually keeping track of the present state of the client connected to it, right. So then what's it doing? The client still has to send it a lot of data, right, telling it what its current state is, but based on that it will look at its own internal state, take the entire client state, compute what it needs and send it back to the client. Okay, under what circumstances is this good? When you have a strong network connection between client and server, right, a client that by itself is not very powerful, right, but a server that is reasonably powerful, or more importantly maybe a large sort of group of servers where you can distribute the load, right, because each individual server is stateless. It does not need to know in which state the client was. It gets all that information, performs the computation and sends the data back. Okay, so from that point of view, a thick stateless server can also be a good way of implementing something like this. These are potential ways of looking at your architecture, right. The common one, of course, at least that we would normally see in a JavaScript and API based approach, would be tending more towards the thin server, right? Meaning that the front end, the JavaScript on the browser, takes care of most of the work for you and just makes API requests in order to decide what needs to get updated on screen. The interesting thing is you can also take these kind of SPAs and in a lot of cases run them locally, right? You can save them as a file, which means that they will now be accessible under a file colon URI, right? And the first time around you download it from the server, you save it to the local file system, but subsequent requests are then served locally, okay? And the interesting thing here is you want to update the app, just reload from the server, right? So the person who is maintaining the app also just needs to update whatever they are serving, right? And that's it, that's like an app update. You don't need to download a lot of information for that, okay? Now when you run locally, of course there are questions such as where do you store information and so on, but there are APIs, right? The web storage API that we have already seen can be used in order to store user information at the browser itself. Now there are several challenges associated with single page application. One of them is how do you optimize for search engine visibility, right? Because after all, what's happening is previously you would have a specific URL that corresponds to each different part of what gets displayed on the screen. But with routers, for example, right, you are no longer able to have that kind of control, or you can, but it's not sort of straightforward, right? Especially when a person clicks through, right, or the web crawler is looking at your page, it's not really seeing all the different links, because crawlers usually don't run JavaScript. They are just looking at the HTML of the page and deciding where to go next. So it's quite likely they will not go through all the router links and decide which ones to sort of look at one after the other, okay? Managing the browser history, like I said, has to be handled with care so that it gives a good user experience at the end of the day. And there can also be problems with analytics, because after all you are loading components, right, internal to the system over there, and not all of them are generating hits onto the main server, okay? And more importantly, things like Google Analytics, for example, would not even get triggered, because those happen only when you explicitly have some kind of a HTML page load and a page refresh, right? If just a component or an API call goes out, that does not automatically trigger a analytics update, okay? Now obviously, since we have been looking at Vue as a framework, a single page application with Vue, what would it look like? Usually you would have something like, all the application logic, the complex part of it would be on the back end on a server, possibly implemented using Flask or some other kind of platform that you know works in terms of implementing APIs, for example, right? The front end state variables, it would be a combination of Vue and possibly Vuex, assuming that you have sufficiently complicated state that you want to use a state management library, right? And the Vue router would then take care of the navigation and page updates, which would now be completely component based rather than individual HTML pages, okay? So that's basically where Vue as a library helps you to construct single page applications, right? You can do it with other frameworks, with React, Angular, there are a whole bunch of different frameworks that can be used in order to construct these single page applications. Vue happens to be one that can be done with sort of a minimum of friction, so to say. Now, we have talked so far about single page applications, right? We can go one step further from there and talk about something called a progressive web application, or a PWA, right? This is a closely related and often confused term, right? I mean, people generally tend to confuse PWAs with SPAs and so on, right? And it's understandable because there are a lot of similarities between the two, okay? And the point is that one of the reasons for that confusion is the fact that very often PWAs are implemented as SPAs, right? But there are certain things that people think of when they hear the term PWA which sort of extend a little bit beyond what a plain SPA by itself is required to have, okay? So the point is that not all single page applications would be considered progressive web applications, right? You could have even something as simple as a blog website being a single page application, but nobody is really going to call that a PWA because it doesn't have any significant dynamic content. There is no notion of sort of offline usage and things of that sort which you need to worry about in a simple SPA, right? On the other hand, it is possible to have something which is actually a PWA, right, a progressive web application, which may not necessarily be implemented as a SPA, right? You could have the notion of offline and web workers which we'll get to in a moment, but where the rendering is done explicitly and you do have new requests being sent to some server and then coming back from that server with a response, okay? But like I said, the most common scenario is that a PWA, a progressive web app, is implemented in the form of an SPA, right, which means that I get to benefit from all the front end advances of SPAs. So then comes the question, what exactly is it that a PWA provides in addition to that, okay? So to understand that, we also need to think a little bit about this notion of what's called web workers, okay? So a web worker is something, it's a script, you can think of it as a script, probably a JavaScript function or set of functions that is started by the web content. What is the web content? It's basically the HTML page that gets displayed. And the idea is that it runs in the background, okay, and a worker thread, right, can perform computations, okay, it can also perform fetch requests. So in other words, it can perform a whole bunch of asynchronous operations. But the interesting thing is, if a worker thread was started or a web worker was started by some web page, it means that that page can communicate with the web worker, it can make requests to the web worker, and more importantly, that worker can then also push events back to the page, okay. So you could have something where the entire sort of interaction between the page and the web worker is a nice sort of back and forth of messages that are going on over there, right. Now what this means in turn is that by having this web worker sitting over here, right, you effectively make it a proxy, right. I mean, I am using the term proxy loosely, this is not exactly the term in which sense in which it is implemented over here, right. What happens is that this page now sort of connects to the web worker and makes requests to the web worker. And what the web worker can do is, if it is online and has access to the server, usually it would then connect to the server, get the information back and then resend it back to the page. Okay, so that is the sense in which it looks like a proxy, right? It's not absolutely required to function exactly this way. It would probably do some processing on it before sending it back to the page. But the important point is, because this web worker is running on your system, not, well, it's essentially part of the browser, right, that is there on your system. What it means is that even if you are offline, your network connectivity is disrupted, the web worker would still have access to some information, maybe previous information or maybe whatever the developer decided should be there, in an offline mode, which it can now deliver from the cache, okay. And this is one of the crucial aspects that sort of makes a PWA an actual web application, right? The fact that it continues to operate and can exist even without the network connectivity and can behave in a reasonable manner even though you don't have the full access to the internet. Okay, that's where it starts behaving like an application rather than just a connection between you and the server. So there are a number of characteristics that define PWAs, right? One of them is the fact that it can be installed, and I'll show you an example of that in a moment, right? There is something called a web manifest that needs to be provided with each PWA, right? And this is basically metadata that helps to identify the operator to the operating system some details about the application, right? In a lot of cases, these PWAs nowadays especially are beginning to use WebAssembly. WebAssembly being a sort of compiled version of JavaScript that can execute faster. It executes in some kind of a virtual machine inside the browser, right? And you have this bytecode that gets generated and can execute over there, potentially faster than vanilla JavaScript. It also has or makes use of the storage APIs, typically web storage APIs, and the worker APIs, the service workers. All of these are sort of common characteristics of PWAs, right? It's not that every one of these has to be present, but most of them are going to be found in various PWAs. So as an example of a PWA, I'm opening this website called app.diagrams.net. It's a website that can be used in order to draw various kinds of vector graphics, right, and can be useful for lots of flowcharts and various other diagrams that you might potentially find useful, right. It's a regular website, right, and it asks me where I want to save the diagrams. I'm just going to say decide later for now. It brings up this menu, right. It's clearly inside a browser because I can see the back button, the refresh button, I can see the URL bar up on the top, right. But otherwise everything else, it allows me to basically draw things over here, right, and change things, write on it and so on, okay. The interesting thing is in the URL bar on the top right, you will see this new icon that says install diagrams.net. When I click on it, it basically says should I install the app, okay, and I can click on install, and the moment I do that, it now opens up in a separate window of its own, right. So you'll notice that it has now opened up in a separate window. That window does not have the rest of the URL bar, the back button or any of those things that indicate that this is a browser. It almost looks like a native application, and in fact I can use it that way, right. I can continue doing the same thing. Of course it still has the diagram that I left off over there, right. I can add more to it, I can make connections and so on, right, use it just the way that I would use it in the regular app, okay. And finally, if I don't want it, I can just go there, I can go and click on app info, find out more about it, right. It tells me a little bit about the connection and so on, right. The site settings, cookies and so on are required in order for this to operate. But the interesting thing is I can also either open it in Chrome, right, in the browser, or I can uninstall the entire app just by clicking on this remove button, at which point it's basically going away, right. So app.diagrams.net is an example of a PWA, right, that can be used in order to install something locally onto your system that you can then use almost like a regular application that you would use on the system. It of course brings up a restricted version of the browser that only has access to that particular website, right, and allows you to work. It also installs an offline mode, which means that even if you are not connected to the internet, you should still be able to work on the system. Right. So that is essentially sort of the notion of a progressive web app. Right. And finally, a word about web apps versus native applications. Right. So ultimately, the reason behind going for a web app is simply because of the ease of development in some sense. Right. You have a very low barrier to entry. But on the other hand, native applications, right, they are typically compiled with a software development kit. There are many of them. There's Flutter, there is the Swift SDK for iOS and Mac applications, several other SDKs that allow you to compile and directly create an executable that will run on a particular platform, right. Now the native apps therefore have the best access to the underlying operating system because they are usually integrating tightly with the APIs provided by the operating system itself and not going through an extra browser interface in between, okay. They will generally look and feel like the native application. So on a Mac, they would look exactly like a Mac. On Linux, they would look like a Linux application. On Windows, they would look like a Windows application and so on, right? But the problem is it may not look uniform across devices, right? On the other hand, a web app, the original Java slogan, right, the Java language slogan that Sun Microsystems came out with in around 1995 or 96 was write once, run anywhere. Right? And the idea was simply that you would write in Java, compile it into bytecode, and then it didn't matter on which platform you were running, whether it was Linux or Windows, right, at the time. You had, as long as you had a Java bytecode interpreter, right, a Java virtual machine, you would be able to run the program there, right. Now of course Java ran into other problems and ultimately made it big on the server scene, but in terms of taking over apps and applets, it was not really very successful, right. On the other hand, web apps have been perfect because they started incrementally. They started with just cleaning up the user interface, HTML and CSS became better, and along the way JavaScript developed more and more powerful capabilities to the point where with a very low barrier to entry, with very low requirements from the developer, you can actually construct fairly complex applications, right? One of the concerns over here, of course, is these are continuously evolving standards. So you need to sort of keep track of what is the latest and greatest, and in order to make the best use of the facilities that you have, right? Even in terms of optimizing the size of the applications, minimizing them, getting like efficient network transfer and so on, all of those. But at the end of the day, we are now at a stage where web applications can come very close to native in terms of the look, feel and performance. And these, SPAs, PWAs and so on are one of the most interesting ways in which we can get to that kind of behavior.